No.
Relax, these are easy. They look really abstract and weird, but they're easy.
What lesson is that?
This is 121. Okay, so if you look at page 662, you look at that graph and you completely freak out, right? Because it's three different things, and how do you do that? Well, it's really easy because all you have to do is take it apart, piece by piece, hence the name piecewise. So if you have something like this, I'm going to try to have the same one, but you sort of get the idea. Okay, so this is what we have. We can separate this just by looking at it instinctively. How many segments would you break it up into? Three, right? This one, which is supposed to be a straight line, just so you know. This one, and this one, correct? If I were to ask you, thank you. If I were to ask you to describe the first, all three of them, what type of functions would they be? Are they circles? Are they parabolas? They're lines, all three of them, right? Wow. So let's look at the first one. How would you find the first one? What's the equation of the first one? And you would find it. You've got 2 points. You can find the M, right? And you can find the B is obvious. What's the B? Right, so this is, and the slope? There's no slope. Why not?
Because it's straight line.
It's horizontal.
So it's 0?
So it's 0.
So it's y equals.
Y equals 1.
Y equals -2. Wait. This is number 1. Easy, right? We're going to go little by little, just for explanation's sake. Okay? Bear with me a little bit. Now let's do number 2. Number 2. What happens with number 2? Same exact thing. It's a line.
But this one has a slope.
This one has a slope. So what would the slope be? You have 2 points. Let's find the 2 points.
It's 1 and 5.
1.
1
Well, you don't have to do all of this right now. We're doing it so you get the point. This is just conceptual. So this would be, you have -2 comma -2. And what's the other point?
1,5.
1 comma 5. That's not 1 comma 5. 5 comma 1. Thank you. Okay, so your M would be
3/4.
how much?
3/4.
3/4? You sure? Trust me.
Trace over 1.
He's so smart. He didn't even look at this. Right? Rise is 3/1, 2, 3, 4. Perfect. 3/4. And if I extend this, it's going to fall on the -4, let's say. Okay? So, my equation for this one is y equals 3/4 of x minus 4, correct? And what's the equation for the third one?
Y equals 1.
Y equals y. Now, we have to, that's defining the functions. Do you agree? But if you notice, if we just leave this way, it means it's a line that goes from infinite to negative, from negative infinite to positive infinite, right? And that isn't true. It starts here, correct? This one doesn't go on forever. It starts here and ends here. and this one starts here and ends here. So, I'm going to define it. I have to use the brace because it includes all of them, right? So I've got that y, the first segment, y equals -2. But from where to where? X is in between what? Less than 2,
Greater than 2.
greater than 0. Does it include the 0 and the 2?
Yes.
So greater than or equal to 2, right?
I have a question on 2. Why is it 3/4 and not 3/3?
Because I don't know, he counted. I trusted him.
Yeah, that's why. it's
Let's see.
3.
1, 2, 3. This is 3. And this is
No, that's 4.
1, 2, 3.
So it's
3 and 3.
And this is 1, 2, 3. It is 3/3. Ideal.
I was like, my brain was.
So 1. Okay. Good.
Why don't you count from 2?
I do. No, because this one goes up. Ah, you're right. It's a little crooked, isn't it?
It's
Yeah.
4.
It's 3.
3.
Oh my
Do
God.
that thing with only the
1, 2, 3. The froggy jumped through it. Okay, so now we go to number 2. And number 2, we now know is x minus 4. From where to where?
2 to 3.
Does it
5.
include the 2?
Five.
Yeah.
Y is greater to 5.
2, 5. Let me make it weird.
Already weird.
Blank. It's a blank. So,
equal to.
just less than 5, okay? Because it doesn't include the 5. And then the last one is
Y
y equal to 1. From where to where?
from
1
5
to
from
5.
1.
Greater than 5.
X is greater than
5.
5. And this is the algebraic way of writing that graph. Is it clear? It's really easy, right? Just take it apart piece by piece. You put it from where to where. That's it. Okay? Now, look at example 121.2. I'm not even going to draw that. Notice that they take the line. That's the equation of the line. And then the other one is a horizontal. And if you look underneath it at the very bottom, it's the equation of the line when x is greater than 0 or equal to 0 because it includes it, and the other one doesn't include it, so it's just greater than 0. Okay? We there? We good there? Is this part understood? Bye. So now we come to the greatest integer function. The reason why I'm teaching that one in particular now is because we're going to see it in calculus later. And I got so excited when I finally understood it. It was like really cool. And I thought, now that I get it, I'm going to explain it before we get to calculus so that when you get to calculus, it doesn't seem so strange. The greatest integer function. First of all, this one has a, just like absolute value has its own symbol, and it's the straight lines. And what else has its own symbol? Well, integrals and other things. The greatest integer function has its own symbol as well. And it's like this. Bracket, it's like a double bracket thing, okay? I don't know how they do it here. They don't do the double thing. But the standard way of doing it is this way, okay? In the book, they do it like this. It's like little tiny brackets. But, I'll do it this way just so that you get used to it for next year, okay? So, what is it? Let me explain where you use it first so that you can understand what it is. When you deposit money in a bank, usually, normally, your money does not earn any interest until the end of the year, which Would you agree?
Yes.
So if you deposit $1,000 today, you don't touch it, you don't, and you put it at 10% interest, you don't see that interest until, if you deposit it on January 1st, 2000, you don't see the money until January 1st, 2001. Do you agree? How much would you see? An extra $100, right? So if we graph money against time, in case you were wondering why I make you write X and Y, because not always X and Y, in this case it's time and money, okay? And I put here years. So this is gonna be 2000, 2001. Let's put it in just 1, 2, 3, 4, okay. When let's say that this is $1,000. This is 2,000, 3,000, and everything in between is divided by 10, right? Okay. When I first deposit it, it's year 0, correct? Because it's the year 2000. I deposit it here. How much do I deposit? $1,000. The whole year goes by, and I get absolutely nothing. Even when I reach it at the end, I get absolutely nothing. But then 24 hours go by, and boom, I am up here. I'm gonna
It is 1,000.
This is 1,000, and this is 1,100. There we go. 1,200. Just to prove a point. Okay. So 1 year, and this is 10% interest, right? The year goes by, and the next one I start up here, don't I? And then I move all the way down here again, and the next year I won't have 1,200. I have a little bit more. I'll be up here again, and so on. Do you see the point?
Yes.
Okay. So for a full year, I only have what I have at the beginning of the year. Do you agree? So let me translate it to this. So at the beginning, I have 1,000, correct? As time goes by, even if I have 1,001, because if 1 day goes by, I'm gonna have a little bit more than 1,000. I just don't see it because it accumulates throughout the year, but I don't see it until that last day, until 365 days later. So if I have 1,001, I still have 1,000, correct? And then I have 1,002 or 1,030, but I still see how much? 1,000. And so on until I reach 1,100. Then I get to see 1,100. And then 1,101, I still see 1,100. Do you see the point? Okay. Now, the greatest integer function was made for this because of money and because of things that behave like that. Okay? So, if I tell you 2.1, that would be equal to how much? 2. If I tell you 2.9, that would be equal to 2. Is it clear why? That is the greatest integer function. Is it clear? Good.